Hello everybody, and welcome to the second video on vectors. In this video I simply want to continue the thread we began last time when we introduced vectors, and in particular I just want to show you how to do three separate things with vectors, and then we will write a program that incorporates all of them. And what I want to do is show you how to sort a vector, how to find a particular entry inside of a vector. So if you have a list of whole numbers, how do you know if the number 7 is in there? So finding things. And the final thing we'll talk about is how do you erase something from a vector? So we already have this popback function that will erase something from the end of the vector, but suppose you don't want to erase from the end. Suppose you want to erase from the middle. I'll show you how to do that. So let's begin with sorting vectors. So of course, when you talk about sorting, presumably you're talking about numeric data, right? It doesn't make a ton of sense unless you put some additional structure on it anyway. It doesn't make a ton of sense to sort strings or booleans or something. And suppose you want to take those entries and sort them from smallest to biggest. It's fairly straightforward. The first thing you need is this pound include algorithm at the top of your program, and then it's just a single command, and this is what it looks like. Sort whatever your vector name is, dot begin, whatever your vector name is, dot end. That will sort from smallest to biggest. So I should say that you all have the tools to write your own sorting code if you think about it. So to sort, you have to identify the smallest number and then move it up front. The second smallest number, move it to the second spot, etc. All of you can do that if I gave you maybe 2 hours to work on it. But I don't want to focus on the sorting so much because I want us to do things with it. So we're just going to steal this directly from the algorithm library, and we will write other code that uses this. Okay, so this is what the code looks like. If you want from biggest to smallest, you can use this reverse command. So the sort command goes from smallest to biggest. The reverse command just literally reverses the entries of your vector, and now they will be from biggest to smallest. So just to show you that, okay, so I have my include vector, but I also need my include algorithm now. Okay, so let me just create a list, and let's just have it, let me just hard code it in. So let's do my vec.push back. Let me throw in some numbers that aren't in order. So I'll put 3 in there, and then I'll put 7 in there, and then I'll put -1 in there, and then I'll put -5 in there, and then I'll put a 10 in there. Okay, so it's all jumbled up. So just to confirm that this did what I wanted, let me print this. So this is the for loop here that always prints a vector for us if we want it to. So let's see out the entry at a particular position, and I'll separate them with new lines. So let's just make sure that our vector is what we think it is. I threw in 3, 7, -1, -5, and 10 in that order, and so notice that is what gets printed. Okay, so now what I want to do is I want to create a little bit more space, and now let me just sort this thing. So sort my vec begin, my vec.end, and now let me just print it again, and we'll see what it does. Okay, so the original vector is still there, and now notice it sorted it from smallest to biggest, -5, -1, 3, 7, 10. And then if I want to list it from from biggest to smallest, all I have to do now is just reverse all of that. So I'll reverse my vec.begin, my vec.end, and just print it out again. and it should go in the opposite order. So yeah, okay, so here's the original one, all jumbled. Here it is after just the sort command from smallest to biggest, but then once it's from smallest to biggest and you reverse it, you get from biggest to smallest. Okay, so that's how you can sort a list if you want to. So now let's move on to something a bit more challenging. Suppose you have an integer vector and you want to know if 1 is in there somewhere. And 1 is arbitrary. You also could search for 10 or 30 or whatever. How would you do something like that? So here's one way you can do it. This will mimic what the string find function is supposed to do, but for some of you doesn't do. But that's all right. This will mimic exactly that. Let's start by declaring x to be -1. And what x is going to do is it's going to record the first instance of a 1 that I find. Because 1 is what I'm looking for. So if you're going to search for 1, it seems to me that the most reasonable thing to do is just to start at the beginning of the vector and go all the way to the end. And if you see 1, then just record that you got a 1. So actually I misspoke earlier. It looks like x will actually record the final instance of a 1 that we see. Do you see why that's the case? So every single time you see a 1, you're setting x equal to the position where you find a 1. Right, so I records position here. So if we see a 1 at position 0, then x would be 0. If we then see a 1 at position 5, then x would become 5. Okay, so regardless, x becomes not -1 if I ever get a hit anywhere inside of that vector. So once you're done with all of this, if x is still -1, that means that you didn't get a hit. If x is not equal to -1, that means you did get a hit, and as I said before, this is a typo here. The last occurrence was at x. So in any case, all you're doing is just changing the value of x to something else, essentially, whenever you get a hit for what you're looking for. So let's just come back over here. So, okay, so I already have a vector going. So let me now set up all of this other code. So int x equals -1. So that's the default value of x. I'm defaulting to not finding anything. And so for int I equals 0, I less than my vec dot size I plus plus if my vec at position I is whatever I happen to be looking for, in this case the number 1, then I will record that as x. Okay, so now I'll say if x is still -1, what does that mean? That means didn't find. Okay, otherwise I did find. So I can say, found it, the final occurrence was at, position, and I'll just say x. Okay, so when I run this, -1 is not in my current vector. My current vector consists of these 5 numbers. So let's run this and just see what it does. Didn't find a 1, it tells me. Okay, so it worked. So what happened was x defaulted to -1, and as I went through my vector and just asked, hey, at my current spot, do I see a 1? The answer was always no. I never saw a 1, therefore the value of x never changed. And so I go into this if statement here. But let me come all the way back up here, and I'll do my vec dot push back, and I'll throw a couple of 1s on there. Let's see what it does then. So now let me run all this. 0, 1, 2, 3, 4. Yeah, okay, so it sorted it for me, right? So notice I create this vector in jumbled order, and since my old code is still there, where I sorted it and then reversed it, this is the vector that my searching is actually looking through. It's starting with the biggest and going to the smallest, and notice 10 is at position 0, 7 at 1, 3 at 2, 1 at position 3 and then 1 at position 4. So I told the user I found it, and oh, the last time I saw it was at position 4. So if you want sort of a cute little challenge, you can think about how to stop it at the first occurrence of 1, if you want to, rather than the last occurrence. It wouldn't take you too much trouble to do that. But at the very least here, this code, if all you want to do is know if a 1 is in there somewhere, this code will do that for you. It detects the presence of a 1 or not a 1, and it will work regardless of what this value is. So if I put a 7 in there, let's see what it does. Found it, and I found it at position 1. And that was the last time I saw it, right? And that's correct. It is at position 1. If I put an 8 in there, didn't find a 1. I didn't change the wording here, right? Didn't find a 1. So I would change that to didn't find whatever the user was looking for, right? So, okay, so here's how you can make your own search or find function yourself, essentially. This is acting just like the string find function that was given to you a month ago. Okay, so before I show you a more involved example, let's talk about the syntax for erasing something from a vector. Again, you can always erase from the end of a vector at the final position using popback. But if you don't care about the end, you care about position 2, position 3, whatever. Here is the syntax that will do that. So myvec.erase, and the syntax here is kind of strange, but just go with it. You got to do .begin plus the place where you want it to erase. So let's put these functions together by doing a program that does like a really bare bones version of the game Deal or No Deal. And so if you haven't seen the show, I think it was popular like 3 years ago, so you people may not have cared about it at all. And you really shouldn't have cared about it because it's kind of a stupid game. But let me just briefly describe to you what happens. There are 26 briefcases being displayed. Each briefcase has a number on it, 1 through 26. Inside of a briefcase is a monetary amount. And the player who's playing can't see the monetary amount. And what the player does is, on each round of play, the player just chooses a briefcase that will be opened. And so what the user is trying to do is get cases to be open that have small money amounts in them, so that as you go, you have more and more cases with big money, which will then make the show offer you more money to quit playing. So the way that the game works is like you just keep choosing cases, and essentially every time you choose one, the show will offer you a certain amount of money to stop playing. So it's better for you to open cases with small money so that as you keep going, there's more money out there, and the show will offer you more money to quit. So that's the way the game works. We are not going to write a full program that deals with all of that. It takes too much time for the purposes of this video, but let's just talk about how would you mimic this. Like, you got a list of cases here, right? So essentially you have a list consisting of the numbers 1 through 26. How could you mimic the gameplay where the user chooses a briefcase and then that briefcase disappears from play? So the briefcase the user chooses gets erased from this list. How could we mimic that? And how could we also mimic that the user can stop playing essentially whenever they want to? So that's not quite what happens in the real game, but for us, let's just throw that in there as a rule. The user removes one briefcase at a time, and they can stop removing whenever they feel like. So let's write a program that mimics all of that. So let me come back up here. Let me just get rid of all of this. So let me just give this a more descriptive name now, briefcases. And initially, and I equals 0, we need 26 cases, don't we? So maybe to make this more clear, let's start with I equals 1, I less than or equal to 26, I plus plus. What are we going to do? We're going to put all of those numbers into my list of briefcases. So what this for loop will do is it will put the number 1 into my list, and then the number 2 into my list, and then the number 3 into my list, etc. So right now, all I've done is create So let's just put my briefcases.size, put my printing vector in there. I've just created the list of briefcases. So just to check that that's what I've done, let's print like we always do. Okay, so it prints 1 through 26. Okay, so there you go. I now have a list of briefcases going. And let's let the user tell us which briefcase they want to remove. So int removed case. So right here, we'll start by asking the user, what case do you want to remove? And then the user will tell us. And then what are we supposed to do? We're supposed to go into this code, find where that case is, and erase it. Okay? And so right now, at the beginning of this game, we know exactly where all of the cases are. We know that case 1 is at position 0, case 2 is at position 1, etc. But as the game goes on, we won't know that. Once the user takes 25, 6, 10, 11 out of this, it is harder to tell where case 12 is. Okay, so if the user takes 6, 10, and 11 out, then 12 has been shifted to the left 3 spaces. So you don't want to keep track of that as the game goes on. So let's just use our code that I just had a second ago. So right here, I'm going to put x equals -1. And let's see, where was that code? Finding an entry inside of a vector. Okay, so for int I equals 0, I less than, in this case, briefcases.size, I want to stop before I reach the end of that list, if briefcases, oops, I should spell that correctly, briefcases at the current search position is whatever the user just asked for, we can record that, x equals I. And then once we're done with that, we can go back to my erasing syntax here. So briefcases.erase. Let me make sure I get the syntax right. So once I've found where that briefcase is, let me just take it out. So briefcases.erase, briefcases.begin plus x. Okay, so what will this do? This will search through the briefcase list until I find the case the user wants to take out, and then I record where that occurred. So briefcases at position I is like 12, 13, whatever. I, though, is the position where 12 is. So 12 could be here at position, what is this, 11 right now? But these other cases have been removed, maybe. So maybe 12 is further down the line. Whatever. So now, once you've found 12, you will record where you found it, and then you will remove that entry from the list with this line of code here. Okay, and so notice that I also need, starting right here, I need a loop to let me just keep doing this. So what would that loop look like? While, let's see, well certainly I need to quit if I run out of briefcases, right? And we should give the user a way of telling us if they want to keep choosing or not. Whoops. So as long as I still have briefcases, and as long as they haven't told me to stop, I should keep going. So back up here, string. So let's just declare some variable that lets them keep going or not. So like right here, let's ask, cout, do you want to stop now? And we'll get that response from them. Okay, so the last thing I want to do in this list here, where's my print? Yeah, so right here I start by printing. Let me put that in here also. So the last thing they'll see before you ask them to stop is that list. Let me just go ahead and put some new lines in. Okay, so let's run this and see if it goes. So again, the global logic here is I create the initial briefcase vector consisting of the numbers 1 through 26. I then ask the user, hey, what case do you want to remove? I then find where inside my briefcase vector that case is. I record that position. I erase the entry at that position, thereby removing the briefcase that the user wanted removed. I then print the list of briefcases back to the user and ask them if they want to keep going or not. Okay, so let's run this and see if it works. What case do I want to remove? I want to remove case 20. Oh, nice. Okay, so 20 is now gone. You see that? Do you want to stop now? No. I want to keep going. What case do you want to remove? How about case 3? Now notice 3 and 20 are gone. So now, like case 26, that used to be in position 25. Now it's in position 23. You see, so that's why I really wanted this search function here because, yeah, I initially know where case 26 is, but I don't necessarily want to keep track of where it is 4 steps from now. And that goes for all these other entries, right? I initially knew where 14 was, but I don't want to keep track of where it is all the time. So I'll just let this little loop do it. Oh, and notice I do, I don't think I have to reset x equal to -1. That won't matter because x will be reset anyway. But in any case, I can keep going, right? What case do you want to remove? Case 10, man. Okay. So notice now that 3, 10, and 20. Those are all missing. Do I want to stop now? I do want to stop, and it stops. Okay. So I'm going to put this code on Moodle, and I should once again say this is a very bare bones program here. There are all sorts of ways you can improve this by adding, validation checks. Like, for example, what if the user says, I want to take out case 30? You should tell them, as long as they do nonsense like that, you should tell them there is no case 30, try again. And we, of course, have not dealt with the monetary amounts inside of the briefcases at all, etc. Okay, so this is not a completed perfect program. But at the very least, this program shows you how you can play around with vectors like this by creating your list and erasing and searching and these sorts of things inside of the list. Okay, so at the end of this video now, hopefully you are now more comfortable with vectors broadly and you've understood how to do the sorting, the erasing, and the searching.